Now we come to the final part, okay, of BNV testing, which is the white box testing. Okay, so previously we have learned on the black box testing. So in black box testing, okay, we only consider the input and the expected output, okay, of a program or function or a module. Okay, but in white box testing, we consider, the tester will concern with the internal structure implementation of the program. This is a verification technique that software engineers can use to examine if their code works as expected. Okay, so this testing takes into account the internal mechanism of a system or component. Okay, this is based on the IEEE 1990. And this is also known as a structural testing, glass box testing, or clear box testing. Okay, so here we are now, okay, in white box testing, and we focus on the basis path. Okay, this is so a software engineer can design test cases that can exercise the independent path, okay, within a module or a unit. So what is independent path? Yeah, I will explain later. Okay, and then the test case that exercise, okay, the logical decision. Okay, we can test the logical decisions, okay, on both their true and false side. Okay, and we can test the loop, okay, the loop at their boundaries, okay, within their operational bounds. And also we can test the internal data structures, okay, to ensure their validity. So there are two strategies, basis path testing, or also called as path testing, and control structure testing. Okay, so now we are in a look into the basis path. Okay, so in basis path there are 4 steps here. Okay, there are 4 steps that have to be done, okay, in this testing. So the basis path method, okay, allows for the construction of test cases that are guaranteed to execute every statement in the program at least once. Okay, that is why we need to identify every independent path, okay, in the program. Okay, why? Because we want to execute every statement, okay, in the uh, program at least once. Okay. So this method can be applied to detailed procedural design or source code. Okay, so now in our program we apply it to the in this example. Okay, in this example later I will show you where we apply this method to the source code. Okay, so these are the steps. Okay, the first one, we have to draw the flow graph corresponding to the procedural design of code. Okay, a flow graph for the um, code. Okay, and then we determine the cyclomatic complexity of the flow graph. Okay, so uh, the result of the cyclomatic complexity, okay, should be the same. Okay, means that the number that we get here, okay, in step 2 should be the same as the in step 3. Okay, so in step 3 we determine the basis set of independent paths. Okay, how many independent paths that we can identify, okay, in order we can find in that program. Okay, so the complexity, the cyclomatic complexity indicates the number of paths required. So you can check, okay. Uh, um, so if you cannot find that numbers, okay, the number of paths, so this that same with the cyclomatic complexity. So you need to check. You can try to find, okay, and make sure that it is the same. And lastly, we determine a test case, okay, that will force the execution of each path. Okay, means that your test case, okay, the data that you will use for that case, okay, will make that the each the path, every path executed, okay, being executed. Okay, now the first step is to draw the flow graph. Okay, this is a basic structure of a flow graph. Okay, for example, for a sequence, okay, this is for a sequence segment. If, okay, if true, if false, and so on. This is for while, okay, while true it will repeat, if false it will, and okay, repeat, okay, repeat until true, as long as it is true, and then case, okay, switch case, okay, and we have more than two options here, okay, because we have switch case here. Okay, so this is a basic structure, okay, of a flow graph. So there are four elements that we need to know, okay, to identify, okay, in this flow graph. The first one is the arrow. Okay, the arrow here is we call it edges. Okay, edges that represent the flow of control. Okay, okay, we have to know these four elements because these elements will be used in your cyclomatic complexity calculation after this. Okay, the circle. Okay, so the circle is the nodes. Okay, nodes represent one or more action. Okay, sometimes in one circle it contains more than one action, okay, or statement. Okay, so the next is region. What is region? Okay, region is area bounded by edges and nodes. So for example, okay, this is a region. Okay, okay, so this okay, so this is region. Okay, this is region. This is region. Okay, this is a region. This is the region. Okay, the areas bounded, okay, by edges and nodes. Okay, next is predicate node. What is predicate node? Predicate node is a node that containing a condition. Okay, so for example, where is it? Okay, here, this is a predicate node. Okay, this is predicate node. Where else? Okay, here, okay, this is predicate nodes. Why we have condition here? Okay, whether true or false. Okay, and also here, okay, it means that there are more than one outgoing arrow, okay, from that node. Okay, so these are all the element that you have to know, okay, in your flow graph. Okay, next is how we are to derive your flow graph. Okay, for example, for this statement, we have statement 1. If E is true, then S2, and if, and then statement S3. So this is the flow graph. Okay, this is the flow graph of this statement. Okay, so S1, if true, go to S2, if false, go to S3. Okay, and here, if S1, if true, then go to S2, if false, go to S3, and S4 is and if, and then go to S4. Okay, next will be okay, this is if A and B, okay, true, go to C, false, go to D, right? And this example, this is for Boolean. Okay, if A or B, if true, go to C, if false, go to D, right? This is for while. Okay, S1, segment 1, S1, while true, it will be true, go to S2, okay, if and then it will okay, as long as true it will go to while, okay, if false go to S3. Okay, and for loop, this is for loop. Okay, S1, and this is for, okay, the for statement. If true, you go to S2, and it will test the increment, okay, the condition here. Okay, the condition, okay, is true, then it will go again to the for loop. Okay, this is a condition to increase, okay, right, the counter, okay, the counter. And if false, it's go to S3. Okay, so these are okay, basic structures lah, okay, of your program. Okay, now this is example, okay, of how you want to okay, get okay, your flow graph, okay, from a program here. Okay, so you have this is a program in C programming. Okay, okay, get the input. We test if n less than 0, print valid. Okay, if n is assigned to -1, else, and so on. Okay, so given the source code, identify the suitable test cases to be enforced in whiteboard testing using basis path testing technique. Okay, so this is an example of final exam question. All right, so here, this is the flow graph. Okay, so this is the first initial flow graph. Okay, so you identify okay from your program. Okay, this the first statement. Okay, this one you enter the okay input enter input if okay s1 okay s2 statement 2 okay, and then the for, and then this because this is for loop, you have to indicate okay uh, the increment here of the counter s3, okay, print s4, and return exit here. Okay, so from here okay it is transformed into flow graph, so you get it like this. Okay, okay, so after this you need okay, I want you to check it carefully. Okay, so enter if 2 go to s1, okay, if false go to s2, there is s2, okay, and then we have 4 there, okay, and 4 this is the for loop. Okay, if false it go to s4, okay, and then it will exit. Okay, so this is the equivalent program for this program. Okay, so you can simplify it okay, to make it easier. Okay, give numbers to the nodes. Okay, so 1, 2, 3. Okay, and we have 9 nodes here. Okay, next is to determine the cyclomatic complexity. Okay, so what is cyclomatic complexity? Actually, it gives a quantitative measure. Okay, quantitative measure of the logical complexity. So it measures the logical complexity of the program. Okay, and this okay the logical complexity this value gives the number of independent paths okay in the basis set, okay, and also the upper bound okay for the number of tests to ensure that each statement is executed at least once, so the upper bound. So this is uh, the number of tests uh, that have to be done to ensure that each statement okay on the program is executed, okay, is tested. Okay, so what is independent path? Okay, so independent path is sorry so what is independent path? Independent path is any path through a program okay that introduce at least one set of processing statement or a new condition. Okay, okay, for example, a new age. Okay, so there are three formula to get the okay to get the uh, cyclomatic complexity. Okay, the first formula is okay number of edges. Okay, number of edges minus number of nodes plus 2. Okay, the second formula is number of predicate nodes plus 1, and the third one is number of region. Okay, so these three formulas can be used okay to calculate cyclomatic complexity. So you have okay just now I have explained on the edges, nodes, predicate nodes, and also region. Okay, so here where we will use that the elements of the flow graph. Okay, Okay, so next let us look how to determine. Okay, so in this step, okay, you will apply the formula. Okay, so you can use any of the formula. There are 3 formulas, and of course you will get the same answer. Okay, so for the first one, okay, number of edges minus nodes plus 2. So number of edges, we have 10 edges. Okay, you calculate that. Minus 9 nodes plus 2, you get 3. Okay, in 2, the second formula, number of predicate nodes plus 1. So predicate nodes, we have 2 predicate nodes. Where is it? Okay, here. Okay, this is one predicate node, and this is the second predicate node. Okay, because we have 2. So you have 2 predicate nodes plus 1. Okay, plus 1, so get 3. And the third one is number of region. So where is the region? So number of region is, okay, this one. Okay, okay, the first is, this is the region. Okay, the overall, okay, the overall flow is one region. Okay, it's considered as region 1. And then region 2 is this one, and region 3 is this, okay, this bounded area. Okay, so uh, this is the psychometric or complexity of the program is 3. And this also means that there are 3 basis paths. Okay, basis path in this program. Okay, basis path or independent path. Okay, independent path. So the independent path here is, okay, okay, remember the independent path means any node square from the beginning, okay, until the end, okay, the end of the execution. Okay, so we have, first is, the first path will be 1 2 3 9. Okay, the second path will be 1 2 4 5 6 7 5 8 9. The third one will be 1 2 4 5 8 9. So there are 3 independent paths. Okay, and remember we have 3, the cyclometric complexity also 3 just now. Okay, so to complete the white box testing process, so you have to test a program with all 3 input sets. Okay, and verify that that the output matches the expected result. Okay, if all outputs match, then the code passes the test. Okay, so this is, okay, from your program just now. This is your flow graph. Then you identify you already get the independent path. Okay, there are 3 independent paths here. So now uh, we want to identify what is the data, okay, for the test cases. Okay, the test cases, and for the data uh, we determine, okay, the expected result or output. Okay, so note that data should be chosen so that conditions at the predicate nodes are appropriately set, okay, as each pass is tested. Okay, so okay, look, now we want to test the independent path 1, which is 1 2 3 9. Okay, 1 2 3 9. Okay, so to test this path, okay, the input should be, okay, if n is negative, if n is less than 0. So you can test with negative 1, okay, less than 0. Okay, so here what we expect is it will print invalid, okay, invalid, and n here, n is negative 0. So you get, negative 1, okay, negative 1. So then it will exit. Okay, if you want to test this path, okay, 1 2 4 5 and so on, 1 2 4 5 6, okay, 5 and 8 9. Okay, so you must here it must, okay, the input should be, okay, n is 1, okay, n is 1, okay, n is 1. So here you go here, else here, and go into this loop for loop, okay, and so it is true, okay, true here, so it will print here, 1, okay, this is percentage is n, okay, n, okay, n is 1, not equal to, not equal, okay, t is 1 now, okay, t is 1, okay, because this is executed, okay, this code is executed, okay, so you get this output, expected output. Okay, to test 1, 2, 4, 5, 8, 9, okay, 1, 2, 4, 5, 8, 9, okay, so the input should be, okay, should be, the data should be 0, okay, because when it is 0, okay, so it is greater than, and now it's greater than 0, okay, okay, so now it go here, but at the for loop here, okay, at the for loop here, it will, okay, it will go up, okay, it will fail, okay, because I is 1 while n is 0, okay, so it will pause here, so it will go to print f, okay, 8, okay, go to 8 here, and it will print, okay, 0 n, okay, not equal 1, okay, t is 1, okay, and will exit, okay, so these are the test cases, okay, that can be derived, okay, or can that came from this program. So you just test for this value n equal to -1, n equal to 1, and n equal to 0. So uh, this is based on the um, flow graph that you already design, okay, and then you get the complexity, the cyclomatic complexity, and then you get the number of independent paths, and this will, the independent paths will guide us, okay, on determining the data, okay, that can be used for the test cases.